We decided to make the classic game Pong with two players. Each player has a bumper where it's used to deflect the ball so that the ball doesn't pass behind the player's wall. If it passes the opposing player's wall, the player scores 1 point and the game ends when one player scores 10 points. We use our death boards as the controllers and we use the tilt functionality to direct the bumpers, but we could also use keyboard controls to control the bumpers. When a player scores, we trigger the blue light on their board, and when the game ends, the green light flashes on the winner's board and the red light flashes on the loser's board.
So here's our system diagram. We have the laptop with the GUI and the Pong client, and then with the laptop we connect via UART to both of the Freedom boards. So on each Freedom board we have the UART that connects to the state machine, which then connects to the LEDs to shine a light when we score, when we lose, or when we win. We also have an accelerometer that also interacts with the state machine and sends its information back to the laptop via UART. So this is duplicated across both boards so that we can use both boards as controls for the Python game. To start the game, first plug in both of the boards into the computer you'll be using, and then you can run the Python script. After Pygame has loaded, a timer will appear for 10 seconds where you'll be able to move the paddles to see which board is which, and this timer is used to clear the buffer in each of the boards that is sending the UART input. To control the paddles, tilt the boards forwards and backwards on the axis where the wire is connected. This allows for you to move your paddle back and forth. To start the game, press T. As you're playing the game, you can move your paddle around and you'll be able to hit the ball. When the ball is hit, its momentum will change along the x-axis and it will go to the other side. Whenever you score on your opponent, your board will light up blue. As you play the game, your score will increase. Once your score hits 10, the game will be over, and the winner will have their board flash green, and the loser will have their board flash red. To reset the game, press R.
The most interesting piece of information that we figured out is that we can both send and receive information using your connections at the same time. We take advantage of this to trigger the lights upon scoring while still at the same time controlling the position of the bumpers. The most challenging part of implementation was getting the UART communication to work properly. We had many issues where either the board or the computer would receive, but the other would not receive at the same time. We also had a large amount of lag when we first started interfacing between the two systems. We believe this is from a buffer filling up and therefore taking a long time to process previous signals.
So something surprising we learned in implementation is that during the testing, we saw that the board would be able to send but not receive. And with this happening randomly when the game started, so we have both players click the reset button as the timer is counting down at the start of the game.
Once we got the UART connection working, most of our testing was play testing and trying to produce edge cases. For example, we wanted to observe what would happen if the ball hit the side of the board. We carefully moved our bumpers until we observed this occurring many times. We had noticed that it would bounce around and act erratically, so we decided that the behavior we wanted was to have it bounce off a single time no matter where the ball came in contact with the bumper instead of this sort of bouncing behavior, and so we corrected this implementation.